Cosmic shortcuts, a glimpse into wormholes. Have you ever wondered if there could be a way to travel across the universe in the blink of an eye? Well, wormholes might just be the answer to that cosmic conundrum. Wormholes, also known as Einstein-Rosen bridges, are like cosmic tunnels. These fascinating structures are theoretical passages through space-time that could create shortcuts for long journeys across the universe. Imagine a shortcut through space-time itself. Instead of traveling the long way around, a wormhole could allow you to take a direct route, bypassing the vast distances that separate stars and galaxies. They could connect distant parts of the universe. This means that places that are light years apart could be linked by a wormhole, making interstellar travel a reality. Journeys of millions of light years might become mere seconds. Imagine the possibilities for exploration and discovery if we could traverse the cosmos in such a short amount of time. Think of it, hopping between galaxies like switching subway lines. The concept of wormholes could revolutionize the way we think about space travel and our place in the universe. This isn't just science fiction, folks. While wormholes have been popularized in movies and books, they are also a serious topic of study in the field of astrophysics. Wormholes are a serious topic in astrophysics. Scientists are exploring the mathematical and physical possibilities of these extraordinary structures, trying to understand if they could exist in reality. They could revolutionize our understanding of space travel. If we could harness the power of wormholes, it would open up new frontiers for human exploration, and potentially allow us to reach distant worlds. These mind-bending structures come from Einstein's theory of general relativity. According to this theory, massive objects can warp the fabric of space-time, creating the potential for wormholes. They act as bridges, connecting 2 points in the fabric of space-time. This means that a wormhole could theoretically link 2 distant locations, providing a shortcut through the universe. Picture it, 2 ends of a tunnel, each opening up to a completely different part of the universe. This visual can help us grasp the incredible potential of wormholes for space travel. It's a heady concept, first proposed by Albert Einstein and Nathan Rosen back in 1935. Their groundbreaking work laid the foundation for our current understanding of wormholes. That's why we call them Einstein-Rosen bridges. These theoretical constructs continue to inspire scientists and fuel our imaginations as we ponder the mysteries of the universe. The catch building a wormhole isn't easy. Now you're probably wondering, how do we find these cosmic shortcuts? The idea of a wormhole is fascinating, isn't it? Imagine being able to travel from one point in the universe to another in the blink of an eye. But the reality is far more complex than the concept. Or better yet, how do we build one? Theoretical physicists have been grappling with this question for decades. The equations and theories are mind-boggling, and the practical challenges are even more daunting. Well, that's where things get complicated. The mathematics involved in creating a stable wormhole are incredibly complex. We're talking about equations that stretch the limits of our understanding of the universe. Creating a wormhole isn't like digging a tunnel through a mountain. It's not just a matter of moving dirt and rock. Instead, it's about manipulating the very fabric of space-time. It's more like trying to fold space-time itself, and that requires some serious physics. Imagine trying to fold a piece of paper in such a way that 2 distant points touch. Now replace that paper with the fabric of the universe. One of the biggest challenges is the need for something called negative energy. This isn't just a theoretical concept, it's a requirement for keeping a wormhole stable and open. Think of it as the scaffolding you'd need to hold a wormhole open. Without it, the wormhole would collapse almost instantly. Problem is, we haven't quite figured out how to generate negative energy on a scale large enough to be useful. Current theories suggest it might be possible, but we're still a long way from making it a reality. It's a bit like trying to build a skyscraper out of cotton candy. The structure is theoretically possible, but practically it's incredibly fragile and difficult to work with. Possible in theory, but tricky in practice. The dream of building a wormhole is still alive, but it's going to take a lot more research, innovation, and perhaps a few breakthroughs in our understanding of the universe before it becomes a reality. Quantum leaps experiments bringing us closer. In the realm of scientific discovery, few areas are as exciting and full of potential as quantum physics. This field, which delves into the mysteries of the very small, is opening doors to possibilities that once seemed like the stuff of science fiction. Even though we haven't punched through to another galaxy just yet, the progress being made is nothing short of remarkable. Our understanding of the universe is expanding at an unprecedented rate thanks to the tireless efforts of scientists around the globe. Scientists are making some exciting progress. In laboratories filled with cutting-edge technology, researchers are pushing the boundaries of what we know. They are not just theorizing but actively experimenting, bringing us closer to breakthroughs that could change our understanding of reality itself. Quantum physics, the study of the very small, is offering intriguing clues. The equations and theories that once seemed abstract are now being tested and observed in real-world experiments. These experiments are providing us with a deeper understanding of the fundamental forces that govern our universe. Researchers are using quantum computers to simulate wormholes and study their properties. These advanced machines, which operate on principles of quantum mechanics, are capable of processing information in ways that classical computers cannot. This allows scientists to explore complex phenomena that were previously beyond our reach. One experiment at Caltech, for example, created a kind of baby wormhole in a quantum computer. This groundbreaking experiment provided valuable insights into how wormholes might function. By simulating these objects, researchers can study their properties in a controlled environment. It wasn't a real wormhole, of course, but it allowed scientists to study how these objects might behave. This kind of research is crucial because it helps us build a foundation of knowledge that could one day lead to practical applications. Understanding the behavior of wormholes could have profound implications for space travel and communication. Think of it like building a model airplane before you try to build a real one. The model allows you to test your ideas and refine your techniques. Similarly, these quantum simulations are helping scientists to test their theories and improve their understanding of complex phenomena. These experiments are helping us understand the fundamental physics that might one day make wormhole travel a reality. By studying these phenomena in detail, we are laying the groundwork for future technologies that could revolutionize our ability to explore the cosmos. The journey is just beginning, and the possibilities are truly limitless. Wormhole highways and energy expressways. The possibilities of wormholes go beyond just faster-than-light travel. Imagine a future where we could harness their power for instant energy transfer across vast distances. This isn't just a pipe dream. Some scientists believe that wormholes could act as conduits for energy, allowing us to tap into distant stars or even other universes. The implications for energy production and consumption are staggering. We could potentially solve our energy crisis and power our civilization for millennia to come. Here's a thought to ponder. What if the universe is teeming with microscopic wormholes popping in and out of existence all the time? Some theories suggest that these tiny wormholes could be responsible for the accelerating expansion of the universe. It's like the universe is blowing itself up like a balloon, with these microscopic wormholes acting as tiny air pumps. If true, this could revolutionize our understanding of the cosmos and the very nature of space and time itself. The energy problem fueling our cosmic leaps. Let's face it, even if we could create a wormhole, getting something through it is a whole other challenge. Remember that negative energy we talked about? Well, it takes a tremendous amount of it to hold a wormhole open long enough for something to travel through. We're talking about energy on a scale that dwarfs anything we can currently produce. It's like trying to fill up a swimming pool with a teaspoon. We need a breakthrough in energy production before we can even think about sending a probe, let alone a spaceship, through a wormhole. Size matters, from atoms to spaceships. Another head-scratcher is the size of these wormholes. Would they be tiny, subatomic things, or could we create one big enough to swallow a spaceship? The answer is, we don't know. The size of a wormhole likely depends on the amount of energy used to create it. More energy, bigger wormhole. But even if we could create a massive wormhole, there's no guarantee it would be stable. It might collapse in on itself before anything could travel through it. It's a bit like trying to build a bridge out of soap bubbles. A future through the wormhole? So will we ever be able to hop between galaxies using wormholes? It's impossible to say for sure. Right now it's still in the realm of speculation. But the very fact that we're asking these questions shows how far we've come in our understanding of the universe. The quest to understand wormholes is pushing the boundaries of physics and forcing us to confront some of the biggest mysteries of the cosmos. And who knows, maybe one day wormhole travel will be as commonplace as a trip to the moon is today. Keep looking up. The universe is full of surprises. The universe is a vast and mysterious place, full of wonders we've yet to even imagine. Wormholes are just one example of the mind-blowing possibilities that await us as we continue to explore the cosmos. So, keep looking up at the stars, keep asking questions, and never stop being curious. The universe is full of surprises, and the next big discovery might be just around the corner. Or should I say, through the wormhole.